Hello everyone, so today we're going to talk about balancing equations. So we're going to start off with a scale. And so on a scale you want both sides of whatever you have on there to be equal. And so it's equal now. So let's add a number in there. So 5 does equal 5. So that's how you want the scale to be. So if we move to another scale that's, let's say, not equal, but we want it to be. So on this side we'll have 5, the other side will have maybe 3. That's not equal. And so this is the essential point with balancing equations. So you want one equation to be balanced and another equation may not be balanced, but that's what you want it to be. So the one with a 5 on each side is balanced, the other is not, because 5 does not equal 3. And so essentially the 5 that equals the 5 is equal. The one, the 5, which is not equal to 3, is not equal. And so this is the whole point with balancing equations. You want both sides to be balanced or equal. So now if we take this to numbers, we have 5 that equals 5, which is equal. And like our other one, when we have 3 equals to 5, that's not equal. And so using the same example, we're putting it in an equation form. And so when you look at it like this, this is essentially an equation. And one is balanced and one is not balanced. One is equal and one is not necessarily equal. And so this is the whole point. You want to make sure that each side of your equal sign is equal. If the numbers on both sides of the equal sign do not match, then it's not equal. So if we continue to look at this in an equation form, let's start with 1 plus 2 equals to, we're not sure, plus 2. So what we're going to want to do is we're going to want to bring our equal sign down. And then we're going to see, we have both numbers on one side, so what is that? 1 plus 2 equals 3. We know that. And so this side has to equal the same thing, so that means 3 equals to 3. So now, on one side we do know we have 3. So let's figure out what's missing on the other side. So we already have 2, so how many do we have to add to get to 3? So it looks like we have to add 1 more to get to 3. So then our missing number must be 1. And so now this equation is balanced, or this equation is equal. And that's what we want. We want to find whatever's missing from one side of the equal sign to make sure that our equation is balanced or equal. And so as we let's look at another example. So we're going to have 3 plus 2 equals to 2 plus, I don't know, there's something missing. So this equation is not balanced, so let's balance it. So we're going to bring our equal sign down, which is our first step always. And on this side we have 3 plus 2, so we know that that equals 5. And so we're going to count out how many we have. And so we're going to count 1, 2, 3, 4, and 5. So let's move on to our other side. So if this equals 5, we know that this side has to equal 5 as well, but there's just something missing. So let's figure out what's missing. And so we know we have 2 on that side, so how many do we have to add to get to 5? 1, 2, 3. So our missing number is 3. And so now, just like before, this equation is equal. It's equal on both sides and it is balanced. So let's try one more example. So we have 8 plus, we don't know, equals 4 plus 5. And so we're always going to bring our equal sign down first. And then we're going to see how many we have on the side where we have all the information. So 4 plus 5 we know is equal to 9. And so we have 9 pieces on this side of the equation. And so if we count out all of our pieces, our 4 plus 5, which equals to 9, then we know on the other side of this equation, we have to have 9. It has to be 9, because 9 is equal to 9 to make this equation equal. So let's count out how many pieces we have on that one side, which would be 8. So that's all of our 8 pieces there. So how many more do we need to add to get to 9? 1. And so we add our 1 piece there, so our missing number must be 1. And so now this equation has been equalized. It is balanced and is equal because 8 plus 1 equals 4 plus 5, which in total equals to 9 on each side of the equation. And so now it's officially equal. So we're going to try one more example. It's going to be a little tougher than the others. So we're going to have 7 plus 3 on this one, which is going to be equal to 3 plus, we don't know, because we don't have all the information for that side. So now, what's our first step? Bring the equal sign down, of course. And we know on this side we have 7 plus 3. And so let's count how much that'll be with our counters. 1, 2, 3, 4, 5, 6, 7. Add 3 more. 9, 8, 9, 10. So now we know on this side of the equation we have 10 pieces. And so we have to have 10 on the other side to make this equation equal. So now what we're going to do is we're going to count how many we do have, and that would be 3. And so how many more do we need to get to 10? So we know we have 3. So then we're going to continue with 4, 5, 6, 7, 8, 9, 10. And so we reach 10, so we have 1, 2, 3, 4, 5, 6, 7 more pieces that we need to get to 10. So our mystery number has to be 7. And so now this equation is, what's our magic word for this? It is equal. And that is what we are trying to do when balancing equations. We want each side of the equal sign to be equal. And so that is our main point in this lesson, is that both sides of our equal sign must always be equal to have a balanced equation. That is what creates the equation and makes it balanced. And that's what you need to know. And so now you can follow up this lesson with the practice worksheet that's attached at the link below. If you have any questions, I'm always available online, of course. And I do hope you enjoyed this lesson.